Once again, welcome back to the online tutor. Today I am going to present a special lesson which is permutation and combination. Permutation and combination is a pure lesson and little bit different pure lesson. In A-level paper we had that question on question number 12 part A and most of the time it's a essay question, but sometimes it might be a structure paper question. But anyway, today I'm going to give a basic idea about the permutation and combination. Actually, this is very popular and very practical lesson, and in permutation and combination we have two separate parts, which is permutation and combination. And today the first video I'm representing about permutation, and on the screen you can see the definition of the permutation, which is a permutation is an arrangement of all or part of a set of objects with regards to the order of the arrangement. The arrangement is on a straight line or else on a circle, and the object can be taken with replacement or without replacement. Actually, what is this replacement mean? The replacement mean normally when we are selecting something, assume that on a box we have three different balls, and we are taking one ball out, and if you put that ball again onto the box, then which is called the replacement, and we are not taking that, we are not putting on ball to the box means which is without replacement. And actually in a permutation we can arrange our elements, our objects on a straight line or else a circle. The circle part is not in A-level syllabus. Now we have only the straight line arrangement. Okay, now I'm moving to the theorem number 1. So the theorem, actually we have 4 theorems, right? This is the first theorem. What is the first theorem? Which is the total number of the arrangement which can be made by taking n number of things is factorial n. I think all of you know about the factorial, so again I will tell you what is the factorial. The factorial is, assume we have n factorial. The n factorial mean n into n minus 1 into n minus 2, likewise up to 1. And factorial 5 is 5, 4, 3, 2, 1. Likewise, the answer is 120. So this is the actually factorial. And so once again let's move to the theorem. The theorem have 3 conditions to be satisfied. Before using the theorem, you might have know the things should be different each other. So it means that the things cannot be equal. Like if you have 5 balls, 2 are white, 3 are black. So this is can't be happen in the theorem number 1. So normally theorem number 1 is focusing the different objects which are different each other. And if the objects are similar, then we have to move to the next theorem. Likewise, right, the second one, the things should be taken without replacement. I told you about the replacement case. The replacement means we are not putting again that the taking item is not put into the somewhere we took it. So this is the second condition. And the arrangement should be on a straight line. So the arrangement should be straight line mean I told you we have 2 different arrangements, but the circle one is not in a syllabus, but so here it's only a straight line. So this is the three conditions to be satisfied when we are using theorem number 1. Okay. So just assume example. Assume we have four friends A, B, C, D, and I just need to put these friends on a straight line, right? So assume in our school SMB we are normally on a queue, no? Then we have to place these four students to that straight line. So what are the how many arrangement that we have to put on these four children? So let's I assume the first A is on the starting point and B, C, D are the normal way, and we have another arrangement which is A is on the front and the B also the second, and I'm just swap C and D, and D and C now it's. So the likewise we can make so many different arrangements. So A is here, and we can move B and D likewise, right? And also the A can be swapped with the others and B come to the front likewise. We have so many different arrangement. So actually this is the main idea about the lesson, right? So we have so many arrangements, so we need to find the total arrangement. That is the main object of the theorem. Right, so let's we'll see how many arrangement that we have. So which is under the theorem number 1, which is factorial lane. So now it's factorial 4 because we have only 4 students now. Then it's 4, 3, 2, 1. Likewise it's 12 and 24. So this is the total number of arrangement that we have using these 4 students. And we have 24 total arrangements. So that is the theorem number 1 actually. That is the theorem number 1. If we have n number of elements, then the answer is factorial n. If we have 10 number of elements, then the factorial is 10 factorial. So likewise, but condition shouldn't be violated. That's the only thing you have to protect, right? Okay, let's move to the question number 1. All the letters of the word triangle are permutated in all possible ways. Find the total number of arrangement without considering any order. Starting with N, starting with AL, starting with AOL, ending with AOL, AL together, AL not together. Okay, so first you have to understand, you have to write the triangle word, right? The triangle word has 8 letters, TRIANGLE. So T is 1 time, R is 1 time, I 1 times, A 1 time, N1, G1, L1, E1, and all together it's 8. Okay, the first thing is you have to write how many words that we have. It's 8, right? And the first row number, they are focusing to how many arrangement that we have using all letters, right? Considering any order, it's 8 numbers letters that we have. Then the first position we can put 8. All 8 can be put into the first position. The second position 7, and next 6, 5, 4. Likewise we can put letters letter by letter like that way. So the 8, 7, 6, 5, like that means it is factorial 8. Okay, factorial 8 means 40,320. This is the answer of the first Roman number, right? It's simply factorial 8, right? So the next Roman number starting with n. Starting with n means you have to fix n. You have to fix n onto the first position, and others can be interchanged. Others can be changed each other. So the first position is fixed, mean we can't change it. Then we have only 7 letters remaining. The 7 letters mean 7654. Likewise, factorial 7. Factorial 7. Factorial 7 mean 5040. Okay, so the next round number, which is starting with AL. Starting with AL mean you have to fix again AL, both, right? Both fix mean we have 6, 5, 4, likewise to the space. So this is factorial 6, right? 720. Okay, so the next round number starting with AOL, right? AOL mean once I am putting A and it's 7, 6, likewise up to 1, it's factorial 7. And now I am considering L, right? L also the same, it's 7, I 6, and right, because here it's AOL, no? AOL mean once I put A and I'm again consider the L, right? Factorial 7 double, 7 factorial into 2. 7 factorial into 2 mean, yeah, that's the answer. Okay, right. Okay, we did first 4 row numbers, right? Right. Okay. So the next one ending with AOL. So ending with AOL mean you have to put AL to the ending position, right? So here we have 8 positions, no? 8 positions, and ending with AOL. So once I'm putting A and the 7 letters can be changed, right? So it's 7 factorial, and also we can put L and it is factorial 7. So the total arrangement is factorial 7 into 2. Ending with AOL, right? This is again O. AOL. Right. So the next one is AL together. So AL together mean AL, I'm bundle AL, and I'm taking AL as a 1 letter, right? And AL is 1 letter mean we have 6 remaining letters, right? The all together it's 7, because considering AL and the other 6, the complete one is 7. So the all 7 can be interchanged, right? So AL is considered as a 1 letter, right? And then the AL is interchanged with the other 6, then it's factorial 7, right? So actually we can consider the LA as well, right? LA as well mean again 7 factorial, because 6 other 6 and this one is 7, then again it's factorial 7, all together 2 factorial 7. So this is the condition of the total arrangement of AL together. AL together mean ALO, LA, both can be happen, right? In both cases A and L are together, right? And you have to understand these kind of situations, right? Right. So the next row number, what we have, look at the this is the 5th one. Okay, so the next one, AL not together, right? AL not together mean you have to avoid that AL together case with the first row number, right? First row number is all letters using the factorial 8, and now it's 2 factorial 7 AL together. AL are not together mean 8 factorial minus 2 7 factorial, right? So the answer is 30,240. Okay, I think now you might have a little bit idea about the permutation and combination, right? How to permutate the triangle word, right? Appropriate way. Okay, let's move to the next one. All the letters of the word chemistry, right? Your favorite subject, no? Chemistry, are permutated in all possible ways. Find the total number of arrangement without considering any order. Without considering any order, the chemistry word, right? Okay, so the chemistry word, again, I'm writing chemistry word, Chemistry, C1H1E1 M1 ISTRY. So all number of letters are 8. The total arrangement is factorial 8. And the first Rome number, the total number of arrangement is 8, 7, 6, 5. Likewise, up to 1. In exam, sometimes you can write it like onto the straight line and you can put it, or else you can directly write the factorial 8. Okay, so for the first Rome number, the answer is factorial 8. Right. Next one, the starting with T. You have to fix T and put the others 7, 6, 5 likewise. The answer is factorial 7. Okay, so the next Rome number, E and R are together. E and R are together. ER together means you have to put ER and the others are interchanged, right? And the other way around, it's RE. R is again can be changed with the other letters, right? It's both cases factorial 6 and 2 factorial 6. So this is the answer of the next Rome number. Okay, let's move to the next Rome number, which is C and T are not in corner. Actually not T, it's CR, right? CR are not in corner mean you have to put CR onto the corner, and we'll see how many arrange that we have with the CR corner, right? CR corner. CR corner mean we have 6 letters, right, with the CR corner, and the answer is factorial 6. And CR is on the corner, right? And we need CR not in the corner. So the first Rome number that we have the total number of arrangement, and I'm going to deduct the CR corner case with the previous Rome number 8, right? Actually CR and RC both can be on the corner, no? In the manner of CR and RC, right? So the answer is factorial 8 minus factorial 6 into 2. This is the answer of the CR not in the corner, right? Okay, please change the question to the CR, right? Not CT. It's a typing mistake actually. Okay, this is the question number 2. Okay, let's move to the next question. 5 girls and 6 boys should be arranged into a straight line. What is the total number of arrangement? The first row number, first 2 students should be girls. First 2 should be girls and the last 2 should be boys. All boys should be together. Okay, first 2 should be, okay, anyway, I'm just writing 5 girls and 6 boys, right? And the first row number, it was 2. The first 2 should be girls, no? And I'm putting a particular girl and another particular girl in, and it will be 5 4, right? And 5 4, and the others can be 6 boys and 3 girls, right? And 6 boys and 3 girls mean likewise we can write 9 8 7 likewise up to 1. And the first 2 is on 2 girls, right? It's 5 into 4, and the others are 9 factorial, because others can be interchanged. But the first row number, the 2 girls are in the corner, no? Okay, the next one, first 2 should be girls and the last 2 should be boys. Okay, that is again like the previous one. You have to put first 2 girls, right? First 2 girls onto the first corner, and the another 2 boys to the last corner, right? And 5 4 for the first, 6 5 for the next. So the either the middle can be 7 factorial, right? The answer will be 5 4 factorial 7 and 6 5. The total arrangements 5 4 and the factorial 7 and 6 5. Right, so this is the answer of first 2 girls and the last 2 boys. Okay, the last one, all boys should be together. All boys should be mean you have to pack the boy, right? You have to pack the boys into one, right? So the all 6 boys into the one packet, and the others are girls. Other 5 are girls, and all together the total number is 6. But actually inside that boys packet, boys actually can be interchanged, right? Here we have 5 girls and 1 boys packet, right? Inside the boys packet, they already they can be interchanged, right? They can be interchanged, right? Likewise, Nimal, Sunil, Kamal is the starting position, then they also can change, you know, then 6 factorial interchange with the boys packet, right? The other one, considering all together we have 6, no? So the all packet of the boys are considered as a one packet, and this 1 and 5 all are 6 factorial. The answer is 6 into 6 factorial, 6 factorial into 6 factorial, because the inside the boys packet they can already interchange, right? And the boys packet and the girls 5 girls also can be interchanged with, but anyway all boys are however the all boys are in together. That is what they ask on that ROM number, right? Okay, right. Okay, this is the end of the question number 2. Let's move to the next question. 16 number of books are on a bookshelf. 3 books are algebra, 4 books are calculus, another 3 are geometry, rest of all the trigonometry. What is the total number of arrangement? Okay, the 16 here, no? I have to write 3 as algebra, 4 as calculus, and 3 are geometric, and the 6 are trigonometric. all are 16, right? What they ask, what is the total number of arrangements? The total number of arrangement means we have 16 books, then all can be interchanged, right? Then factorial 16. They all can change each other, right, without considering any order. If the same type books are together, find the arrangement. The same books are together mean the calculus and the coordinate and the trigonometric coordinate all are bundled, right? So we have 4 bundles. 4 bundles is factorial 4, but inside the bundle they all can interchange, right? The 4, 3, 3, 6 likewise they can interchange, right? Then this is the answer. But however, here the same books are anyway, they all are together because we bundle the books by their name, right? And we can interchange inside the bundle, but however it's a changing, it's the bundle can be changed in factorial 4 inside the 3, 4, 3, 6 likewise. Okay, this is the next example. Okay, so now I think you might have a little bit idea about the first theorem. Now you can do this example as a homework, right? Homework, the universal word, you can permutate it, right? Okay, let's move to the theorem number 2. The number of ways in n things may be arranged among themselves, taking all at a time, when p things are equal, right? We have n number of elements and the p things are equal, and also q things are another kind, right? R things are another type, right? The actually p types mean inside the p the all are same, right? Inside the q all are same. I told you about the same types, no? I told you if we have same things, right? See, it's same thing, same copies, then we have to move to the second theorem, no? The second theorem is strictly focused. We have n number of things and p, q, r likewise the things are equal. Then the total number of arrangement, is factorial n divided by p factorial, q factorial, r factorial. You have to divide by the equal elements, right? The p of things are exactly alike, q things are exactly alike, r things are exactly alike, right? Likewise, these things are equal with themselves. This is the second theorem, right? Okay, let's move to the question. All the letters of the word alliteration are permutated in all possible ways. Find the total number of arrangements. Okay, this is like the previous cases. First thing, you should write the word and write down the number of things: A, R2, L2, I2, T2, R1, O1, N1, and also E1, right? All together it's 12, right? 12, but you can see A, L, I, T has 2 letters, right? The total number of arrangements. The total number of arrangements is factorial 12 divided by we have AR2 the same 2 and I2, right? 2, right? Always we are dividing by the repeating elements, right? The number of repeating elements should be divided. Okay, so the answer is 16. Yeah, factorial 12 over 16. Right, so the next question: all the letters of the word parallel are permutated in all possible ways. Find the total number of arrangements without considering any order. Find the arrangement all else are together. Okay, the parallel word, right? Find the total number of arrangement without considering any ODF, right? The first thing is you should write the parallel word. No, we have to write the parallel word. Parallel word, we have one P, double A, one R, triple L, and one E. All together it's 8. 5, 8, right? 8. And the first Rome number, they ask the total number of complete arrangements. So the total number of arrangement, is factorial 8 should be divided by the equal cases, factorial 3, factorial 2. This is the answer of, you have to write it at 8, 7, 6, 5, 4, and factorial 3 into factorial 2. 3 are getting cancelled, and 2 also cancel with the 4, it's 2, and 56, 30 and 2, 30, 60, 6, 30 and 32 divided, 3,360. This is the answer of the first. Okay, what they ask for the first Rome number, all L's are together. All L are taken as a one bundle, right? But the inside the bundle we can't change each other because all are same, no? So the bundle of L is taken as one letter, right? P are 2, A are 2, P are 1, A are 2, R 1, and E1, and all together 4 and 6. But L can't be interchanged because all 3 letters of L are same, right? It's no point of changing inside the bundle. Right, so all 3 are taken as 1. Right, it's 6 the 6, right? The total arrangements with all L's are together, it's 6 factorial, but you have to divide by 2. Divided by 2, then it's 6, 5, 4, 3, 2 into 2, 1, 2 are cancelled. 6 into 5 is 30, 4 into 3 is 12, right? This is the answer of the first Rome number. Okay. The answer is 360. Right, so let's move to the next Rome number. All L's and A's are together. The arrangement of all L's and A's are together. So the likewise, as a previous case, I'm putting L as a one bundle, and another A here. The answers are 3,360. The first Rome number 360. The next Rome number was all L's and A's are together. All L's and A's are together mean we have to consider L as a one bundle, A as another one bundle, right? L, triple L as a 1, and double A as another one kind. Right? Others are same, right? P R1, P1, E1, all together it's 5. All the bundle of L as considered as a 1, right? A as another one kind. All are 5, right? So the all L's and A's are together mean here we have 5, no? 5, then the answer should be factorial 5. It's 5, 4, 3, 2, 1. 26 and 1. 120, right? This is the answer of the 7 Rome number. All L's and A's are together. First Rome number, it was all L's are together, right? Third one, what they ask for the third Rome number, find the arrangement all else are together but not A's together, right? But not A's, right? The first row number, what we did all else are together. The next one, else and A's are together, but here else are together but A's are not together, right? So you can see there's a pattern, right? The questions, there's a manner, right? The all else are together, all else and A's are together, all else are together but not A's. Here the first row number is 360, no, the second one 240. You have to deduct 360 by 250, 240, because all else are together is the first row number, second row number all else and A's are together. When you subtract it, when you deduct it, you will have all else are together but not A's. 360 minus 120 is 240. This is the answer of that row number. So this is the normally basically they are giving some hint for the last row number, right? Hint was the usage of the first two row numbers, right? If they are using hence or something word, hence find the that, then you will pretty sure you can directly write, you can directly understand, but they are focusing, right? However, so this is a link, right? Okay, anyway, the calculus word, right? All the letters of the word calculus are permuted on all possible ways. Find the total number of arrangement without considering any order. Find the arrangement all C's are together. Okay, the calculus word, right? The calculus permuted in all possible ways. Calculus word C2, A1, L2, U2, S1, all are 8. So the total number of arrangement, which is factorial 8 divided by 2 factorial, 2 factorial, 2 factorial. The next row number, find the arrangement all C's are together. C as C, both C are considered as one letter. A1, L2, U2, S1. Together it's 7. The C's are considered as one bundle, and the factorial is 7. Total arrangement is factorial 7 divided by the same things, 2 factorial, 2 factorial, because L and U have 2, 2. And the next one, all find the arrangement of all C's and L's are together. Sorry, L's are together. L's as 1, C2, L1, U2. Likewise 7. The total arrangement is 7 factorial divided by 2, 2. Okay, next one, the final one, find arrangement all C's and L's are together. Then both C are considered as a one letter. And here we have 3 row number. That is 3, 5 and 6. All 6 letters. Factorial 6 divided by factorial 2. Here this is the arrangement of C's and L's are together. Okay, so this is the end of the tutorial, right? So today we discuss about what is a permutation, and we discuss only 2 theorems, right? This is about the permutation, right? The arrangement, and theorem number 1, theorem number 2. Right, this is the homework that I have gave you under the first theorem. This is another homework, represent word, and here these two also another 2 homeworks. You can try it right? I will publish the answers to the comment section after 2 days, right? But before that you have to do it, right? Anyway, thank you very much for being with us, and don't forget to subscribe my channel. And the next tutorial I will publish permutation and combination second tutorial.